Hello everyone. In this video we will discuss the different coordinate systems and how do we convert them from one coordinate system to another coordinate system if you're given any point. So the first one is called Cartesian coordinate system, or it is also called as rectangular. Another one is called cylindrical, and the third one is called spherical coordinate system. So if you are given a point P in the rectangular coordinate system, we know that a rectangular coordinate system is in 3D is x, y, and z mutually perpendicular. So they're making an angle of 90 with each other. This is x-axis, this is y-axis, and this is z-axis. So if you have a point x, y, and z, you can see that on the x-axis you draw a line parallel to y-axis, and then on the y-axis you draw a line parallel to x-axis. They intersect each other somewhere at some point, and then you take that point up as many points of z whichever is given. So you have to take it up to the point which is the point of z. So this point is called, we call this any general point P, x, y, and z, and this is called the Cartesian coordinate system point in the Cartesian coordinate system, or rectangular coordinate system, usually called as rectangular coordinate system. The next one is cylindrical, and what is the difference between cylindrical and rectangular is that you convert the x and y into the r and theta. So again you take x, the line parallel to y-axis and parallel to x-axis, they intersect at some point. Now we find out the distance from the origin 0, 0 to that point. That is denoted by r, and this is the value, the transformation of x and y into r, the value r, which is now cylindrical. And then you find out the angle theta, which is the r making with the x-axis. So this is the theta. Now you can see that on the xy plane, if you have seen the xy plane, if you have r as, for instance, 1, if you have 1 radius, then it makes a circle. So if radius is 1, and then 1 radius circle would be of this type. So this would make a circle. Why does it become the cylindrical is that if you make a circle and then you take this circle up to a certain z value, that becomes a cylinder. So that's why it's called cylindrical coordinates. So it means the r and the x and y are transformed into r and theta, and the z is as it is. So now you can see this is making a shape of a cylinder. That's why it's called cylindrical coordinate system. And the third one, and you have to remember that since this is a circle, it's making a circle, r and theta is making a circle, so r has to be either 0 or greater than 0, positive, or theta would be between 0 to 2 pi. If we go to the spherical one, you can see that this is exactly the same thing. R and theta is already there. It means that we have to use r and theta now, and then you go up a certain point z. Now we have to transform that point z. So for that you have to draw a line. Similarly, we do exactly the same way that we draw this radius r. Now you have to find out this radius from the origin to this point P. So this was the length x and y, so you have to find out with x and y. Now this is with x, y, and z. So rho would be a radius with x, y, and z in 3 coordinates, and phi is the angle that this radius is making with the z-axis. So if you combine all of them, that gives you, this is the radius that we are talking about, so that is rho, then this is the exact same angle theta, and then this is the angle phi, which is the radius rho is making with the z-axis. Now you have to remember that again, rho is a distance, so it has to be either 0 or positive, and then the phi angle is only on the positive z-axis, so the positive z-axis means it has to be from 0 to pi. Now let's come to the conversion. So we have x, y, and z given in the rectangular coordinate system. How to transform that into r, theta, and z, and rho, theta, and phi. So if you are given x, y, and z, what do we require is r and theta, because z is not changing in cylindrical. So if you're changing it to cylindrical, z is the same, only x and y are changed into r and theta. So r, you can see, is the distance, which is, and you can see that r is the, by Pythagoras theorem, since this is an angle of 90, this is a hypotenuse. So it's the square of x and the square of y and a square root. So according to the formula, r is equals to x square plus y square whole square root, because that is according to hypotenuse formula. And z is not changing, and tangent is again by the formula. So if you have this x and this is y, right, or if you say this is x and this is y, then according to the formula, theta is tangent theta is base over adjacent, base over hypotenuse, base over perpendicular, or you can just, the base is y and the perpendicular is x. So this is making an angle 90, right? And this is the base, and this is the perpendicular. So this is perpendicular over base. So tangent theta is equals to perpendicular over base. Now, if you want to convert the x, y, and z rectangular coordinates into spherical coordinates, what you have to do is, again, rho is the distance from the point x, y, and z. So that is again x square plus y square plus z square, and tangent theta is exactly the same, y over x, and the only difference is now is cos phi. So that you have to draw from here. You can see that the perpendicular is the base is z, and this one is your this one is your x square plus y square plus z square is equals to rho. Now, if you are given a cylindrical coordinate system and you have to transform them into rectangular and spherical, then again you can see that x is equals to r cos theta from the physical laws, that if you have a vector r, then this is r cos theta and this is r sin theta. So from that perspective, you can see that your x is equals to r cos theta, y is equals to r sin theta, and z is equals to z. And similarly, if you have to transform this into spherical, theta is not changing, exactly the same theta. Rho is now, instead of x square y square plus z square, we know that x square plus y square is equals to r square. So this x square plus y square is transformed into r square plus z square, and tangent phi is equals to r over z. Similarly, if you are given spherical coordinates, you can transform that into cylindrical coordinates x, y, and z. And for that, you know that x is equals to r cos theta. In spherical, your r is rho, right? Rho sin phi. So x is equals to rho sin phi cos theta, y is equals to rho sin phi sin theta, and z is equals to rho cos phi. So you can find out the x, y, z rectangular coordinates using these formulas. And if you want to transform this spherical into cylindrical, then theta is not changing, so theta will remain the same. R is now rho sin phi, z is rho cos phi. So you can substitute the values and you can transform from one coordinate system to another coordinate system. Let's solve some of the examples. So let's start with the These are all the formulas I have written down over there. Now you have x, y, and z rectangular coordinates are given. You have to transform that into cylindrical coordinates and spherical coordinates. So to transform that into cylindrical coordinates, we know that r is equals to x square plus y square. Here x is 4 and y is minus 4, and we can see that 16 plus 16, which is 32, and this can be further simplified if you want to. So that would be 4 into 2, right? You can do that is 16 times 2. So 16 square root is 4, and 2 stays inside the square root. Now the next thing is z remains the same. So let's go to the r is found. Need to find out theta. For theta, we know that tan theta is equals to y over x. Y is equals to minus 4. X is equals to 4. That gives you minus 1. So where is tan theta? Minus 1. Remember that theta is between 0 and 2 pi. That is from between 0 to 360. So tan theta, we have for tan theta minus 1, you have two values of theta. That is 3 pi by 4, which is between 2 pi, and 7 pi by 4. You can use calculator to find out theta is equals to tan inverse of minus 1. This will give you only one value, so that's why you have to find out all those thetas for which tan theta is minus 1, and that is 3 pi by 4 and 7 pi by 4. There are many more, but we are dealing the theta values in the range of 0 to 2 pi. So these are the two values of theta that comes in the range of 0 to 2 pi. Now, which one would be the answer, or how many you can have an answer is, there will be one of these two answers, and which answer this could be is you have to find out that one from these 2 points, x and y value. So you can see that x is positive and y is negative. So which quadrant has x positive and y negative is the fourth quadrant. And if you look at these values, this does not come in fourth quadrant, but this one comes in fourth quadrant. So your theta value is 7 pi by 4, which is 315 degree, which comes in the fourth quadrant. So your theta value is this one, and z we says is not changing, so z stays as this one. So your r, theta, and z has been found, and those values are 4 square root 2. Theta is 7 pi by 4, and z is not changing, which is exactly the same. Now to transform this into spherical coordinates, rho, tan, rho, theta, and cos phi, which is phi. So rho is equals to x square plus y square plus z square. We know that is 4 square, we know that is minus 4 square, and that is 4 square root 6 whole square. If you take the square root of these, that gives you 16, that gives you 16, and that is 16 times 6 is 96. And if you add them up, that should give you a value of 128. And when you take out that from to the square root, that is 64 times 2, and the square root of 64 is 8, so 8 square root 2 is the answer. So your rho is at square root 2. Since tan theta is y over x is exactly the same, so from tan theta we already have found this one. Minus 4 into 4 is minus 1, and we found that theta is 7 pi by 4, is actually the same as the previous one. Now the last thing that remains is cos of pi. Cos phi is z over x square plus y square plus z square root, which you can see is the value of rho. So instead of writing all that thing, we already have found rho, which is 8. So we will just write down here rho, and then the value of z is 4 square root 6, and that one is 8 square root 2. You can see that that becomes 1 over 2, and you can write this as like this, and this gives you square root 3 over 2. So phi would be cos inverse of square root 3 over 2, which means you have to find out which value of phi gives you square root 3 over 2, and using calculator or anything, or if you have some other information, you can see that this is pi by 6. So cos 30 is actually square root 3 over 2. There are other values as well, but we are looking for phi between 0 and pi. So this is the only value that lies between in this range. So our rho, theta, and phi values are 8 square root 2, 7, theta is pi by 6, and phi is this over, this, and phi is this one. Now you are given cylindrical coordinates, a point r, theta, and z, and you have to transform that into a rectangular and spherical. So if you have to transform that into rectangular, that is r cos theta, r is 4, cos and or theta is pi by 3, cos pi by 3 is 1 over 2, so that gives us 2, right? And then y is equals to r sine theta, r is 4, sine pi by 3 is square root 3 over 2, so that cancel out each other, and you have the answer 2 square root 3. And we said that z is not changing, so z is minus 3. So your x, y, and z coordinates are 2 square root 3 and minus 3. Now to transform that into spherical coordinates, rho is equals to r square plus z square. So r square, we have r square, r is 4, so the square of 4, and z is minus 3 to the square of 3. That gives us 16 plus 9, which is 25, and the square root of 25 is 5. Now if you have to transform the theta over here, so theta is not changing, theta is the same, so we have pi over 3. And the last thing is that you have to change into phi. So cos phi is equals to, according to the formula, r over z. So that is equals to r is, we already know r from somewhere is 4, z is minus 3, and this implies that cos phi is cos inverse of or minus 3, and that you have. So if we look at this one, cos phi is r by z, which is 4 over minus 3, and cos inverse of 4 over 3. This gives you something greater than 1. So either minus 1 or 1. This is something greater than 1. In cos we say that is between 1, minus 1, and 1. Cos theta always give you value between 1 and minus 1. So if you look at this one, this value is greater than 1 or less than minus 1. So it does not come in range, that's why it is invalid, and it will not give you the value of phi. The last conversion example is if you are given spherical and you have to transform that into spherical to rectangular and spherical. So the formula would be rho sine phi cos theta, rho is 4, sine phi is pi by 4, and cos pi by 3. Sine pi by 4 is 1 over square root 2, and pi by 3 is 1 over 2, so they cancels out each other, and that gives you 2 square root 2, and if you do this simplification, that gives you square root 2. Similarly, for y is equals to rho sine phi sine theta, so sine phi is exactly the same. There is only a bit of change over here, so 4 1 over square root 2, and sine phi is square root 3 over 2, so that again cancels out. Is with a 2 you can do a 2 is 2, and square root 3 cancels out, so you are left with square root 6. Now the last one is x, y, and z. Z is rho cos of phi, so rho is 4, cos of pi is in this case pi by 4, and that is square root 2, which gives you 2. So we can do this as 2 times square root 2 square root 2. It cancels out, and your answer is finally square root 2, because you can write down 2 as a square root 2 square root 2. So now you have to transform. You have transformed into rectangular. Now you have to transform into spherical, to cylindrical. In the cylindrical, we said that theta does not change, so theta is pi by 3. What we need to know is find out the r. So we are given the spherical, and we need to find out r. So the formula is rho sine phi. Rho is 4. Sine phi is pi by 4, which is square root 2, and we have already found that out, which is this one is exactly the same, so this gives us 2 square root 2. Pi is this one, this is our z in the previous one, this is y, and that is x. In the cylindrical, theta is pi by 3, r is 2 square root 2, and now we need to find out theta. We need to find out, in the cylindrical we have r, theta, and z. So the z is rho cos of pi. Rho is cos of pi is again pi by 4, and it would be exactly the same, because pi by 4 for sine and for cos are the same. So z is also 2 square root 2. So I hope you understand the different systems and how you can transform from one system into another system.